Welcome back to Think Design Work Smart. I'm Alex Bolboaca and I'm coming at you from the Mozaic Works studios, and what I have for you today is a brief presentation on code generation and on what code generation tools exist, what types of code generation there are, and what can we expect from code generation to happen in the future. As usual, we love comments, so please leave comments if you find anything interesting that I didn't discuss. Maybe you have some questions, maybe you have some other things to mention. It's always good to have a good conversation on the channel. So let's start by talking a little bit about what we'll talk about. We'll discuss about fundamentals, about types of code generations, typical tools used that exist for code generation, my personal experience using code generation, and a little bit of a look in the future. So what we'll talk about is fundamentally any technology that allows us to generate code. And we'll see that there are multiple types, but this includes the standard ones based on templates, the ones from your IDEs or your code editors, the ones built in various programming frameworks, but also AI, large language model generation. And let's talk a little bit about the types of code generation that exist. First of all, we have a starting template for various projects, and these are often included in your IDs. When you create a new project, you rarely create an empty project. You usually start from existing templates, and these are useful, but there are also specific tools, as we will see, that allow you to use templates. Then there is a kind of code generation which I call Big Bang code generation. This one, the perfect example is tools that start from UML diagrams and generate everything for you. If you define in your UML diagrams components and then classes, maybe, they will generate all the files, everything there is for you. And the third one is a more incremental way of building, of generating code. And here the example that is very common is Ruby on Rails, which was then followed by other technologies, where you generate artifacts one by one as needed. So in Ruby on Rails, basically what you'll do is first you'll generate a project structure, and then you'll go and start generating, let's say, a model entity, a domain entity, and then from there you generate a controller, and you generate a view, and then you start modifying those. And this has been adopted after Ruby on Rails in other technologies as well. And as we will see, I believe this is one of the best ways of doing it, although none of it is perfect. Let's talk a little bit about tools. There are a few tools you can use for code generation. First of all, the most commonly used one is IDEs. I think everybody has used IDEs. Another one that I mentioned, specialized tools, the ones that take, for example, UML diagrams, or ones that take any other kind of initial template and generate you projects for you. But what I think many developers don't know is that there are some tools that are general and open source, and two of them that I can mention are Cookie Cutter and T4. Cookie Cutter is a Python tool, but you can install it everywhere and it doesn't require any Python knowledge. And there are a lot of templates for cookie cutters. You can create all kinds of files, projects that you need to do. And there are people submitting and contributing with various templates. And T4 is also similar, only I think is .NET and not Python. And these two tools are very useful, in particular when I started doing more code for my own learning and for other people's learning. It was very useful to have these tools that allowed me to create code bases and initial project structures without having to use an IDE. And you can do this in a command line, find the right cookie cutter templates and run them. The equivalent, of course, is to create your own structure, but in these structures tend to be fixed or very templated, let's say very similar for various technologies. You have to structure the code in a certain way for Java, in a certain way for .NET, in a certain way for Python, although in Python you have slightly more flexibility. But in order to have everything set up, like having testing set up, having the source code, having the way to run tests, the way to run production code, the way to package everything, it's useful to have these tools. And of course, something similar you have in your IDEs. And then there are the newer version of code generation, which are AI tools, for example, GitHub Copilot. And we'll talk a little bit about each of those. So IDEs, they have the advantage that everything is inside your development environment. You don't have to think that much. You just click create new file or create new project, and it will just give you a template that you can use. You pick from the templates and you go from there. These also tend to be more tested than others, so it's easier to use them. In general, one of the issues with code generation is that we generated code, but then things didn't work. So we had to go back and start fixing things, and it's always more complicated to do that than you'd expect. But in IDEs, since these are tested, it's pretty easy. It's also, in modern IDEs, you can generally find options to create your own templates, but this is not an easy thing to do. Yes, it works for simple situations. When you start having parameters, it starts to get quite complicated, and if you have multiple different situations. With general tools, specialized tools, same thing. Personally, there was a trend at some point that we would generate everything from UML, because UML would be describing a lot of the stuff that we needed, and we won't have to do any more programming setup and stuff like that. But it didn't work that well. And generally, what happens is that you need a feedback loop. So you do the architecture, you do UML diagrams, but then once you start writing the code, you realize that the diagrams are not quite as what you need, and then keeping in sync the diagrams with the generated code, it starts to get quite complicated. So personally, I prefer to craft these things by hand whenever possible, or use very simple incremental tools. Now, the AI tools are promising to be very helpful, but until now, what it seems to me is that they are very useful for research. Like when I don't know how to do something, I can ask an AI assistant to give me some code, but then I use that in my research, not necessarily as generated code. It's more like an inspiration. I'm looking at what it generates, I'm understanding what it does, and then, okay, now I can write the code. So my personal experience is that code generation sounds like a good idea, but one thing that we need to take into account is typing is not the bottleneck. Typing is not the bottleneck. That's not the main problem with programming. The main problem is that we have to think around and to think about specific problems and how to solve them in a very detailed way. And I've never seen that I get too much productivity out of code generation with some very small exceptions. My general process with code generation has always been I generate code, I then look through it, read it, and then I have to fix things, I have to simplify things, I have to refactor, I have to fix things because sometimes there are bugs, sometimes it doesn't compile, things don't fit. I have to simplify and refactor because generally the generated code that the tools had as output was not great. It was much more complex than what I needed. Then I need to write tests, so it's not much faster. And okay, maybe you say this code was tested, but if it doesn't compile, how tested was it? I cannot trust that. So yeah, it's pretty complicated. And by the end of all this process, it's actually slower than writing the whole code from the beginning, so, unfortunately. And once again, typing is not the bottleneck. Now, an assistant that can give me some ideas, that's helpful. And that's as far as I will go with AI assistants. However, it works well in limited conditions, particularly in this incremental code generation. I use that in Rails, but I used it more in Grails, which is the Groovy or the JVM version of Rails. And there it worked quite well. And we could also adjust the templates based on what we need. Well, slightly adjust. So it really worked well, but in a very limited context. And I can see some situations where I would have loved to have additional templates. However, writing your own templates for code generation is non-trivial. It is a development task like any other development task. You have to write it, you have to test it, you have to make sure that it works. Or you just, write it, try to use it, you see it doesn't work, make some changes, it doesn't work again. And often you get annoyed and stop using the template, which is a waste. So writing your own templates is generally non-trivial. Copying some of them and adjusting them, yeah, that can work. Now, so my general advice is don't try to use big bang code generation. You can use, of course, for generating initial project templates. You can use for incremental development, and you can use LLM for research. And that's basically where we are with code generation. Now, what will happen in the future? It's I don't see a lot of progress, despite the advent of LLMs. Oh, it looks like code generation was taken over by AI, but LLMs have a bunch of issues, copyright issues, for example. So In one case in US, there was a decision that says that things generated by AI are not copyrighted by anyone, which is a problem, because if you generate your code using an LLM, that means you don't have copyright, or the organization you work for doesn't have copyright for it, at least in the US. Now, of course, these are issues that might be difficult to prove, or okay, how easy can you prove that code is generated by an LLM? It can be complicated from the legal perspective, but if you want to be on the safe side, the thing you can do is to use LLMs as research tools, but not use their generated code. There are legal issues beyond copyright, like was that infringement? What if the LLM is generating code that is actually taken from another code base that is, let's say, open source, and you use it into a closed source, and then somehow they can prove that you did that? It doesn't matter whether you used an LLM or not. What matters is the code the same or similar? And if it's the same or similar, you may breach the copyright owner's rights. And this leads to other legal issues. And the next thing is, the only way I see myself using an LLM is I will generate code, I will read it, try to understand it, fix it, test it, simplify it, and then continue, which means that it's quite similar to, from the perspective of efficiency, is the same thing as if I would write my code. So for me, LLMs are very good, or can be occasionally very good research tools, but we still need to write our own code. And this leads us to a conclusion that, templates are more predictable than LLMs. People understand the context of the code, while LLMs don't. And no matter what people will say who try to sell this, no, LLMs don't understand the thing. They are merely, so we say, or they say, that LLMs occasionally hallucinate, but that's not true. They always hallucinate. That's the way LLMs work. Or, yeah, so because of this, people understand the context. People will be more reliable in the near future in understanding and writing the code. And it might be interesting to combine LLMs with templates. So I think one area where maybe we don't have enough information is, what if we try to generate templates using LLMs? Like give them a set of similar files and say extract a template for that. This would be an interesting process, and maybe it's not necessarily LLM, it's an pattern extraction thing. And maybe this is something that AI could do. Maybe it's a large language model, but maybe it's one of the other AI techniques for pattern extraction. So this could prove interesting, because if we write by hand 10 different files that look kind of the same, maybe we can extract a template out of that, and maybe an AI would do this faster, better than people would. But yeah, who knows? That's an interesting area of research that I haven't heard about. So that might be very useful. Okay, so my general conclusion and recommendation is, sure, use code generation, but be aware that things can go wrong, and that they may fail. It depends a lot on how the templates are tested. If you are using LLM code generation, then there's a problem there. There are legal and copyright issues there. So ideally use LLMs for research and not for generating code. And in general, use code generation in limited areas, in context that you understand and where the act of actually validating, changing, and so on, it's quite easy to do when writing and testing and so on. The more you generate, the more you need to look into. It's like you'd create legacy code, that is code that you are afraid to change, but automatically instead of doing it manually. So I'd rather craft the code as much as possible. So this is the brief presentation on code generation. What do you think about this? Let us know in the comments. And also, are there situations when you found code generation helpful? Are there situations when you found code generation very unhelpful? What is your opinion on generating with LLMs? And ask us questions if there are any other things that you'd like to learn about code generation. Thank you kindly for the view, and until next time, remember to think, design, and work smart. See you next Saturday.